Okay, today I wanted to talk about describe the solution to problem C. Codeforces round 343, division 2. So this was actually, I think fewer people solved this problem compared to problem D. So during the contest, it was probably a better idea to skip this problem unless you knew how to solve this. But the solution is actually really nice. And yeah, I wanted to talk about that. So first thing to notice is that n minus m is really small. But m and n are really big. Goes up to 100,000. So what you have to do, what you can do, is say, so we need to create a string of length n, and then we are going to have string s of length m, and we're going to have something here, and then something here, and these could be many different things. And we want to count the number of possibilities for these guys. And since n minus m is not that big, it's actually possible to do some sort of slightly brute force type of approach. You don't have to come up with a magic formula that just gets these numbers and then calculate the answer in O1. So what you can do is to check for length. You can iterate over all the possible length for p. I'm just gonna call length p. So this could be 0 or 1. This could be up to n minus m. So we check all the possible length for this guy, and then for each of them we are going to check all the possible numbers of opening parentheses and then closing parentheses, or closing brackets. So I'm just gonna use L to denote the number of opening parentheses, and R for closing. So L could be 0, 1, up to length of p, and then length of p minus L. This is going to be R, because the number of opening brackets and closing brackets in this, when you sum them, it should be the total number of the length of this string. And obviously L has to be bigger than R. Yeah. And then what we need to do is to have some sort of logic to figure out how many ways to create a string of length p. String of length just length p, such that it contains L and R brackets, while satisfying the property that any prefix contains more opening than closing, or the same. So for that purpose, we can do dynamic programming. So we can have some sort of so this is the number of strings with L opening brackets, R closing brackets, and then what you want to do is to so that no prefix contains more opening more closing brackets than opening brackets. And this is actually not a very difficult thing to calculate. So dp of 0, 0, this is 1. And then dp of LR is basically L minus 1 R plus dp of LR minus 1, where you want to add this if and only if L minus 1 is at least R. And you want to do this only if R is at least 1. And the reason for that is pretty simple, I guess. But yeah, let me double check that I'm giving the correct answer. Yeah, actually this it doesn't really matter, but the way I did it was if L is at least R, because L minus 1 R, this, yeah. Anyway, with this recursion, you can find dPLR for each possible number, and then use that to calculate the number of possible values that go in here. Then, as soon as we know the number of opening brackets here and the closing brackets here, and opening brackets here and closing brackets here, we will be able to identify the number of opening brackets and closing brackets here. And then using this, we can actually reuse the dp again to calculate the number of possible values that go in here. So we wanted to make sure that no prefix contains more closing brackets than opening brackets. And what that means is that if you take the suffix has the exact, any suffix has the exact opposite property. Basically, any suffix is going to have, well, actually no suffix has more opening brackets than closing. Does this sound familiar? This is almost the same as this, except that it's in the opposite way. But we don't really care about it when we do the calculation. So when we know the number of opening and then closing parentheses in Q, in Q, we just need to calculate dp RQ LQ. Notice that here I'm putting R and L in the opposite order, but it's because we're doing this suffix and opening closing thing in the opposite way. And then basically you just need to multiply this and this, take the product for each possible length of P and each possible length of length of L and R. And then, yeah, when you add them up, you will get the correct answer. And then make sure that you do the modulo, because there is no way that the answer for some input can fit in a 32-bit integer. I will also attach my solution in the comment section, so feel free to refer to that if you have if my explanation wasn't clear. Thank you very much for watching.